Welcome to lecture number 104 of Digital Electronics. In lecture number 103, we have discussed about an introduction to shift registers. In that, it is already mentioned that there are four functions of shift registers. One is serial input, second one is parallel input, third one is serial output, and fourth one is parallel output. Now, see, the first two ones are based on input. These two ones are based on input, and these two ones are based on output. Now, for a register, there should be input as well as output. This input can be in serial form or parallel form. Similarly, output also can be in serial form or parallel form. Now, for example, if I am considering a serial input, serial output shift register, that is SI, SO shift register. How the data transmission is taking place there? How the data transmission is done in serial input, serial output shift register. I will just give a brief idea on that. So, suppose I am having four flip-flops. I am just representing it by four square boxes. Okay. Now, data is coming in from here. Okay. After the first clock burst, the output of the first flip-flop will be transferred to the second flip-flop. Next clock burst will be transferred to here. In the next clock burst, it will be transferred to here, and at last it will come out from this flip-flop. Okay. So I am considering this as flip-flop 1, 2, 3, 4. Okay. That means here what happens is that if 1 0 1 0 is going in, initially 0 will be coming here in flip-flop number 1 in the first clock. In the second clock, that 0 will be transmitted to flip-flop number 2 and 1 will come here. In the third clock, I will write it here separately. During the first clock, what happens is that 0 is coming in and 1 is kept out. Only one bit can be stored. In the second clock, 0 will be transferred to the second flip-flop and 1 comes in. In the third clock, this 0 will be transmitted to the third flip-flop and 1 will be transmitted to the second flip-flop and this 0 comes in. Okay. Now, in the next clock, this 0 will be transmitted to flip-flop number 4. Here you will get 1 will be transmitted to here, 0 will be transmitted to second flip-flop. Now, at last you will have what? 0, and at last you will have 1 here. Now what happens? At 1, this is 1, 2, 3, 4. At the end of 4th clock, all the data are coming to inside of these registers. Now how it will come out? In the 5th clock, which will come out? 0 will come out. Okay. In the 6th clock, this 1 will come out. In the 7th clock, again 0 will come out. In the 8th clock, what happens? 1 will come out. Okay, that means it is coming in it is going in like 0 1 0 1 and coming out like 0 in at the 5th clock 0 will be coming out. At the 6th clock 1 will be coming out. At the 7th clock 0 will be coming out, and at the 8th clock 1 will be coming out. Okay. So that is basically how data is transmitted in serial input and serial output shift register. Okay. Now coming into data transmission in now say it is serial input, parallel output. We are having combination like that. Okay. Serial input, parallel output shift register. That is SIPO. Serial input, parallel output shift register. So how do you deal with the data transmission in that? How data transmission is happening in that? That is a question. That is a question what is arising here. Now see, here the input is in serial format and output you have to take parallelly. That means from each flip-flop you have to take the output. That is already difference here. That means suppose I am having 4 flip-flops here. 1, 2, 3. Okay, I am taking a 4 flip-flop as square boxes. Data will be coming in here. Okay. The data will be transmitted to here. In the third clockwise it will go in here. The fourth clockwise it will go to next clock. Like that it will happen. Okay. And output is coming in parallel. Okay. So here we have serial input and parallel output. Now let me explain how that is happening in serial in parallel output shift register. I am having same here 1, 2, 3. So you are having a serial input. Say I am choosing 1, 0, 1, 0. This is the data in. That is 0, 1, 0, 1. That is my data. Okay. Now this is transmitted here. Okay. So this is flip-flop number 1, flip-flop number 2, flip-flop number 3, flip-flop number 4. Okay. This is f of 1, f of 2, f of 3, f of 4. Now in the first clock pulse, what happens? 1 will come out from here, right? So 1 is taken out. In the second clock pulse, what happens? 0 will go in. So what happens? 1 will be shifted to here, and 1 will be coming out, and 0 will be coming out from this shift register, from this first flip-flop. In the third clock, again 1 is coming in. So this 1 will be 1 will be coming out from flip-flop number 3. 0 will be coming from here, and 1 will be coming out from here. In the fourth clock, you will get 1 will be shifted to here. 0 will be shifted to here, 1 will be shifted to here, and 0 will be shifted to here. So here what happens? In the fourth clock, you are getting the entire output 0, 1, 0, 1. In the fourth clock, because you are having 4 parallel outputs. You are having 4 parallel outputs. That means in 4 clock pulses, you are getting that output. Okay. So that is regarding serial in parallel output shift register. Now coming into now that two combinations is over. Serial input, serial output, serial input, parallel output. That is over. Now coming to parallel input, serial output. Okay. Third combination is parallel input, serial output. That means input is given in parallel form and output is taken in serial form. So let us check how that happens. Okay, 1, 2, 3. Say I am having 4 flip-flops. Data is parallel. Okay, parallel data in. Okay. Now we are taking the data out in serial. So here you get serial data out. Okay. Now let us check how this is functioning. Say I am give you an example. I am having 4 flip-flops. Okay. Say I am having 1 as input, 0 as input here, 1 as input here, this 1 as input here. Okay. Now in the first clock pulse, what happens? Here I need to check only this output. Okay. So 1, 2, 3. In the first clock pulse, what happens? This is flip-flop number 1, 2, 3, 4. Okay. In the first clock pulse, what happens is that this 1 will be transmitted to here. This 1 will be transmitted to here, and this one will okay, and this 0 will be transmitted to here, and this one will come out. Okay, and this one will be transmitted to here. Okay, so initially in the first clock pulse itself, you are taking this one out. Now in the second clock pulse, what happens? One, this one is there, along with second one will come out, then 0 will reach here, this one will come here. In the third clock pulse, what happens? One is coming, or already one is coming in, now 0 will be taken out, and this one will be shifted to the last flip-flop. And in the fourth clock pulse, this one is fed out from here, so we will get 1 0 1 1. So this is the serial data. This is the serial data which is coming as output. That is, here what happens? In the fourth clock pulse itself, you are getting whatever is you are given in parallel form, you are getting it in serial data output. Okay. That means in 4 clock pulses, whatever is the data which is given in parallel input will come as serial output. Okay. So that is regarding parallel input, serial output shift register. Now coming to the last type. Last type is what? Last type is parallel input, parallel output. That's it. Next one is parallel input, parallel output shift register. Okay. That is PIPO, parallel input, parallel output shift register. Okay. So that is, if I am drawing a 4-bit shift register, that is having, you are having input data are in parallel input data, and outputs are also parallel. Okay, outputs are also parallel outputs. Yeah. Now, how that is happening? That is the next question. There is no transfer from data from flip-flop number 1 to flip-flop number 2. Okay, there is no transmission like that. Okay. From flip-flop number 1 to flip-flop number 2, there is no transmission of data. Now let us see how it is happening. 1, 2, 3. So this is flip-flop number 1, flip-flop number 2, flip-flop number 3, flip-flop number 4. Okay. All are given with the same clock pulse. So let the data in be 1 0 1 1. In the first clock pulse itself, what happens is that this one will come out, this 0 will come out. In the first clock pulse itself, again here this one will come out and this one will come out. That means in parallel input, parallel output shift register, you need only one clock pulse. You need only one clock pulse to get the output. That means here data is fed in parallelly and data is taken out parallelly. So that is the case where you need only one clock pulse. Now, coming into a little bit different type of shift registers, there is bidirectional shift registers. That is the general concept. Bidirectional shift registers. Bidirectional shift registers means it is basically serial input, serial output shift register. It is basically serial input, serial output shift register. But only difference is that data can be fed in from the left side or right side. Okay, that means here if you are having data in from here, okay, data in from here, you can have 4 shift register, 4 flip-flops. Data out can come like this in serial form. Similarly, another way is you can take the data in from here and pass the data to left side and data out will come here. Data out will come here. Okay. So that is basically bidirectional shift registers. Okay. So here only thing is one extra bit which is used to control the direction of data. Control the direction of data is there. Okay. That is one extra bit. That is not in the flip-flop. You have to give one extra bit. Now another one is rotate right and rotate left. Rotate right shift register. Rotate right shift register means, okay, here the data is basically in a rotational mode. 1, 2, 3. Data will be passed from first flip-flop to the next, then here, then here. From here, the next one it will come to here. Okay. So this is how the data flow is happening. So it is basically rotational shift register. So from the last flip-flop, the data is fed back to the first flip-flop. Again, the same process is happening. Rotate left means, here what happens, from the rotate left means here the only difference is rotate left shift register. In rotate left shift register, only difference is the direction is opposite. That is the only difference. So data will be flowing like this to the left. And from here it is fed to the last one. Okay. So that is how the data is. Traveled. So that the only thing what we need to take care is data will be transferred from one flip-flop to another in one clockwise. One bit of data will be transferred from one flip-flop to next one in one clockwise. Okay. So here I have just explained, in this test I have just explained what is done by what are the different types of inputs that can happen in a shift register. It can be serial input or parallel output. And what are different types of outputs that can happen in a shift register, that is serial output and parallel output. Now I have explained about data transmission, how data transmission is happening in serial input, serial output shift register. Second type is serial input, parallel output shift register. Third type is parallel input, serial output shift register, that is PIS. I am just explaining about the data transmission part only. Okay, circuit I will explain in the next lecture. Next one is parallel input, parallel output shift register, and the last one which I have mentioned is bidirectional shift registers and rotate right and rotate left shift registers. Okay. So rotate right shift register means it is data in is from the left side and going out to the right side, and the entire right side data is fed back to the left side. That is rotate right. Whereas in the rotate left, everything is taken from the taken out from the left and it is fed back as input to the rightmost flip-flop. Okay. So that is, so here I have just mentioned about how data is flowing in a shift register. Okay. So in the next lecture we will be dealing in detail about circuits of shift registers, that is sealed SISO, SIPO, then PIPO and PISO. That we will be dealing in next lecture. Thank you.